All right, Chapter 7 starts out with radicals. This is somewhat of a review. We've already looked at them, your perfect squares. If you don't know them, write them out. Pause the video. A couple things to look at over here. When you have the square root of 9, that is just 3. If it's a negative square root of 9, that is a negative 3. The square root of negative 9 cannot be done, however, we know that that is 3i. Correct? That's your imaginary number. So what we're looking at today, though, is just the positives. So let's do some examples. Now, this I'm going to briefly go over because we've done this. All right, 32 can split to 16 times 2. And when you do the square roots, the square root of 16 is 4. And the square root of 2 we do not know, so it is 4 root 2. Okay, those we've done. The number in front just means we multiply. So if you were to split 20 to 4 times 5, when you do the square root of 4 is 2, so 3 times 2 times root 5 would be 6 root 5. All right, variables underneath the radical sign. What you want to think about here is, you know this is the square root, so 2 goes into 2 once. All right, and if you look at that, x squared is x times x. So the square root of x squared is just x. Now, with x to the 6th, that can be written x cubed times x cubed. So if you think about it, 2 is you're doing a square root, 2 goes into 6 3 times. So it is x cubed. Now, with x cubed, 2 doesn't go into 3. Okay, so what you're going to do is break that down to x squared times x. The square root of x squared is x times root x. Okay, so basically, when you're doing radicals, because of the fact that we add, for example, let me write it down here, x to the 4th times x to the 4th, we add our exponents, that'll be x to the 8th. So when we do the square root of x to the 8th, basically 2 goes into 8 how many times? That's 4. So it would be x to the 4th. Okay, so another example where it's, say, x to the 9th. We would break that down, x to the 8th times x. Okay, you break it down to the next even number. Square root of x to the 8th is x to the 4th, root x. Okay, so we'll do some more examples. So here, x cubed and z to the 5th, you can always split them up to look like that. All right, now with x cubed, that can be broken down to x squared times x. Z to the 5th can be broken down to the z to the 4th times z. Square root of x squared is x. Square root of x we don't know. Square root of z to the 4th, 2 goes into 4 twice, so z squared root z. And then what's on the outside stays on the outside, so xz squared. What's on the inside stays on the inside. Okay, and that's breaking it down. All right, for this one, the 12, x to the 7th, and y to the 5th. And don't forget the 7 on the outside. 12 breaks down to 4 times 3, so that would be 2 root 3. X to the 7th, we're going to go x to the 6th times x. Square root of x to the 6th, 2 goes into 6 3 times, so x cubed, root x. Y to the 5th goes down to y to the 4th times y. Square root of y to the 4th is y squared times root y. You have 2 x cubed, y squared, and then root 3xy. Okay, so it's just breaking each part down. The next one, x squared minus 8, that whole thing to the 8th power. Well, it's a square root. 2 goes into 8 4 times, so your answer is just x squared minus 8 to the 4th. Okay, and just think about that. If you multiplied x squared minus 8 to the 4th times x squared minus 8 to the 4th, same base, add your exponents, 4 plus 4 is 8. With this one, no, you cannot break that up and do square root of x squared, square root of 4x, and square root of 4. Doesn't work like that because you have a minus and a plus. So in one like this, where it's a trinomial, or here it was a binomial, you actually just look at factoring that. when you factor that, what multiplies to give you 4 that adds to give you -4 is -2 and -2. Or that is the square root of x minus 2 squared. Square root of x minus 2 squared is just x minus 2. Okay. Next, multiplying radicals. What's on the outside stays on the outside. What's on the inside stays on the inside. Simplify first if you can. Doesn't matter. You can multiply and then simplify. You can simplify first. It doesn't matter. Okay, you kind of decide what works best in each situation. So with this one, root 5 and root 10, yeah, you can multiply them. Be root 50. 25 times 2. So square root of 25 is 5, root 2. Next one. I can multiply what's on the outside. That's 12. Now 27 breaks down to 9 times 3. So I know that's going to be 3 root 3. And then 24 breaks down to 4 times 6. So that's 2 root 6. So I have 12 times 3 times 2 is 36 times 2, which is 72. 3 times 6 is 18. Now here I can also break down 18. 18 is 9 times 2. So now I have 72, square root of 9 is 3, times root 2. 72 times 3 is 216, root 2. Next one, square root of x to the 4th. Well, the square root of x to the 4th we know is x squared. And then x to the 5th we can break down to x to the 4th times x. Square root of x to the 4th is again x squared, root x. So we have x squared times x squared. 2 plus 2 is 4, so x to the 4th, root x. Alright, this one. Again, you can combine the insides and then break it down, or break down each one separately. Doesn't matter. So, looking at this, I think I'm going to combine my variables first, but then keep these separate. So I have root 15 times root 50. And then I'm going to do a to the 5th times a to the 3rd is a to the 8th. B to the 4th times b is b to the 5th. So starting with my numbers, I know 50 is 25 times 2. And the square root of 25 is 5. So it's going to be 5 root 15 times root 2, which is 5 root 30. And there's not a perfect square that goes into 30. So that stays. And then here, 2 goes into 8 4 times, so that's going to be a to the 4th. 2 goes into 5, that doesn't, so that'll be b to the 4th times b. Square root of b to the 4th is b squared, root b. So now all together, here, here, and here, I have 5 a to the 4th b squared times the square root of 30b. And that would be your final answer. Okay? Remember, keep track of what should be on the outside, what should be on the inside. Make sure you don't forget a step along the way.